This video is going to help us go over several problems on our homework for 11.2. Before we begin, I want to talk about a few things in Ed that I played around with. So when it asks us to put them as a point, it's pretty easy. We just go and we click and it will make a point for you. If you don't like it, you can undo. Or if you've made so many that there's just want to reset and start over, there's a reset button. You can also move a point once you've made it by switching over to the Move tab here. So if you want to make a point, all you do is click where you want the point to go. If it's not where you wanted it, you can always move or try again with the undo. So there's also a polygon. And when I'm on here, so I make my shapes. So I click. And when I'm finished, if I want to make it a shape, I can connect it, go back to your last one, and it will fill it in as a completed shape. So I can do 3 points, make a triangle. I can make my quadrilateral here, make it 4 points. If I need to move it to a different place, I can do that. So, and then we can undo or reset our whole page. So let's look at number 3 here. So number 3 wants us to graph these points. So 3, 3. Let me get my marker here. So we're going to, so I notice it's counting by twos, but the scale goes every 1, 2, 3, 4. So every box is a unit. So over 1, 2, 3, and then a positive 3 up 1, 2, 3. So here is A. Then we have B at -6, and then +1 goes up. Here is B. And then we have C, -3, 1, 2, 3, and then +1 is here C. So these are 3 of the vertices of a parallelogram. So parallelograms have 4 sides, so we need 4 vertices. So we need to figure out where could the 4th one be located. So I'm noticing to get from B to C, that was not a straight line, but 1, 2 takes 3 units. That means to get from A to D, it also needs to take 3 units. So 1, 2, 3 will make that the same. So I can connect B and D. I can connect A and C here. So there's one way I could make that parallelogram. So I can see it went over 3, over 3. So if I'm looking to get from B to D, I went up 2 and over 1, 2, 3, 4, 5, 6. If I go from A to C, I go up 2 and over 1, 2, 3, 4, 5, 6. So we have to do the same thing to keep them even. So if the segment AD was completely in quadrant 1, so right now it's on the axis, it's not in quadrant 1 over here, where would point D be located? So we need to try a different location for point D here. So this time, let's try connecting A and B instead. So to get from A to B, I went up 2 and over 1, 2, 3, 4, 5, 6, 7, 8, 9 units. So we're going to connect B and C. So from C, I need to go up 2 over 9, up 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. So D could be here when I connect those. So this time I have a really long, skinny parallelogram. Sorry, my drawing is not great, but so we can connect B and C, A and D. And now segment AD is completely in quadrilateral 1. So if I am graphing that in Ed, so we know we had, let me get my polygon. So we come back. So what are we, now my head's in the way. So 3, 3. So over 3 up 3 was A. And then I went B was negative 6, 1. So negative 6, 1. And then C was negative C, negative 3, 1, negative 3. What's that? Oh, that's because this is a 1, not a negative 1. Oh my gosh. So A here was over 3, up 3. B was negative 6, positive 1. C was negative 3, positive 1. And so then I want to make D go over 3 from A. 1, 2, 3. And I can connect it back together to make that long, skinny parallelogram. So it looks similar to what I had here. So let's go ahead and try number 4. So we want to make 3 coordinate points to make a right triangle. So we've got to have that 90-degree angle in one of the corners. And that should say 2, not toe. So I can choose 2 points that have different X and Y coordinates. So I'm going to choose here and here. So they're different X and Y. So this is over 6 up 2. This is over 1 up 5. Then we need to find a third point and figure out where is it going to be compared to these. So remember, we want to make that right angle. So that means these lines need to come straight out to make that triangle. So here, let's write down our points. So this one was 6 over 6 up 2. Here we have over 1 up 5. And then here we have over 1 up 2. So what do you notice about this last point compared to the first point and the second point? So something I noticed is that these two y coordinates are the same, and these two x coordinates are the same because they need to line up with each other. So the third point has an x coordinate that is the same as another one. We went over the same distance, so the same coordinate as one of the points. So these 2 points shared a common x. And then the other point is going to share a common y. So one has to be x the same, one has to be y the same. Number 5 tells us that a right triangle XYZ has vertices X, Y, and a right angle. So that's important to notice, our right angle. What could Z be? So let's start with graphing. So we've got -2, -1, so going down, 1 over 1 up 1. So we want to make a right angle. So if I connect X and Y, where is Z going to be a right angle? So we can see if we go straight down and straight across, here's one place Z could be. But we could also flip this triangle. Instead of going across, we can go up and over. So here are 2 choices that Y or that Z could be. It could be this or this to make that right triangle. So we're going to graph these and decide which polygon these best match. This is number 7. So we want to go over to the left, -3, down -1. So left -3, down -1. So there's A. Let's label these so we know what they are. B is -3, -3. So here's B. C is +4, -3. So I can see that B and C share the same y coordinate. They're both -3 down. And then D is going to go over 4, down 1. So I can also see that A and D share the same y coordinates. So these are the same. And then I can see that these share x and these share x. So this is what makes this have nice straight lines, is that everything has a matching partner. So what kind of names can we use to describe this particular shape? So I noticed it's closed in and has straight lines. So this is a polygon. So what kind of polygon could it be? So remember, quadrilateral doesn't have 4 sides. If it does, we check that one. So a square has to have equal sides. Does this have all equal sides? If it does, we'll check square. So I'm just going to make a note that that means 4 squares are equal. Trapezoids have one set of parallel sides and the others are going to crisscross. I notice that the top and the bottom are parallel and the sides are parallel. So this has 2 sets of parallel sides. A parallelogram needs 2 sets of parallel sides, which we just said it had. So a rectangle needs parallel sides and it needs 90-degree angles, 4 of those. And a pentagon has 5 sides. So choose the ones that compare and show what this polygon is. Okay, we're also going to do number 8 here. So it says that Diana is drawing a parallelogram on a coordinate plane. So we can see here, she did -2, -2, so in the third quadrant. She did over +2, down -2, so we can see that these can connect together. And 0, 1, so did not go over, it just went up. So what we want to do here is decide which of these will make a polygon and a parallelogram. So if I go over 2, up 5, if I connect these, does that make a parallelogram? So next we have -4, +1. So if we connect all of these, is that a parallelogram? I can see they went down 1, 2, 3, over 2, up 1, 2, 3, over 2. So their patterns seem to be the same on that. So our next ordered pair is at -3, +1. So does this shape, oh, I missed the dot there. Does this shape here make a parallelogram? Watch what's going to happen if I continue on with these lines. So is this a parallelogram? Next, we have over 4, up 1. So I can see to get here, I went 1, 2, 3, up, over 2. And I went 1, 2, 3, up, and over 2. So these are both going at the same angle here. So is this one a parallelogram? Next, we have over 1, up 0. So does this one make a parallelogram? All right, our last one here is 0, -5 down here. So I'm going to use these line tools to help me connect these. So I want to connect those two here, which looks like the same angle here. And then we're going to connect going the other direction. Didn't quite hit that line. Let me move this one just a tiny bit down. And that is the same as this one here. So sometimes it can be hard to see when they're turned. We can turn our head and look at it a different way. We can also, if you're doing it on paper, just turn your paper a different way. So let's try that out. So let me group these together. Let's just try turning this. When I look at this here, This is a parallelogram. The top and the bottom are never going to touch. Neither are the sides. So it just maybe looked like a little different shape because we had it going sideways. But once we turn it, we can see that, yes, that will make that parallelogram. Hey, if you have any other questions with your homework, please let me know. So just remember, we want to go over on to walk to the elevator, then the elevator can take us up and down. Hey, let me know if you have any other questions on your homework and how I can help you.